will be talking a little bit about something we built, and then we will go into mainly a few things that we've learned along the way. And so I'm Jacob, and this is Mats.
Hello. I'm Jacob's sidekick here. I'm not so good at talking, so he's the sweet talker, and I'm just here to disturb him a bit.
So if you get lost, fall asleep or something, this is basically the outline that we're going to give you some background, basically a situation of what it looked like, and then our solution, and then, as I said, some learnings that you might find useful. Many learnings. So we're from the Swedish University of Agricultural Sciences, and we have fancy buildings and campuses and things like this. And we work a lot with data and researchers in Sweden, and there is this, I guess, problem in Sweden. Is that the way we want to phrase it? Right, well, I mean, all the other, it's something you might find surprising about Sweden is data and geographical data is not free. All the other Nordic, Scandinavian countries have this. We don't. And that turns into a problem for researchers because it's a disadvantage to them, a large disadvantage. And not only that, but once you get data, it's generally in really strange formats, and it's not very user-friendly. So what ended up happening at most of the big universities in Sweden that actually had money to begin with to get data was that there would be one researcher, and he would actually organize the data, and it would end up on a USB drive somewhere, and then that would be passed around, and that would be basically data distribution at universities. So at some point, that was just not good enough. So some people got together. Our university, what do we call it? The Yeah, so Vetenskapsrådet, it's a place you can apply for research grants.
Science board or something.
So, yeah,
it's the science board.
The science board, all right. And then Lantmäteriet, which is the bottom one.
Land survey.
The Swedish Land Survey. So at some point, what do we call them? So at some point, the research grant people, they said that this doesn't work, and also it was a disadvantage to small universities because they didn't have money to buy data, whereas the big ones did. So they wanted to settle that, and the Land Survey agreed to that, and so we had to build a service. Yeah. That was basically it. Yeah.
Well, we got money. That's.
Yeah, I mean, who would have thought that those people could get together and sort out the administrative bits? So we had said that we could build a service, and we actually had to do that.
Yeah,
at this point.
We got funding for the data, and we got funding for setting up some kind of distribution solution.
Yeah. So the idea is basically this slide. I don't think we're going to get into it too much, but generally we built it around FME server. We built our own little servlet, if that's interesting to you, that plugs into FME server and does some user validation and things like this, because we have to be certain that the people who get data out of this service is some sort of researcher. So because data is not free and it's not open in Sweden. So it kind of looks like this, and we'll skip that. It's not very interesting. This is what the thing looks like, and we might be able to show it at the end, but what you do is basically it's a map window. You select an area, what you're interested in, and from over here you can select what layers you want, and then you go ready, and it shoots off an FME server
But you should
workspace.
tell more about some nice functionality there. The RISA, if you take too big an area, you will get another. You're not allowed to take you can't take the whole of Sweden in one order. So there is some intelligence in the application. So
Yeah.
yeah.
Yeah. We can show it later if you want.
Okay.
But so some tricks that we learned along the way developing a service like this. The handouts are all the code and stuff that we've used that are relevant to these examples is in the handout. You can just grab one at the end, or there's also a link at the end of the presentation where you can find the handout. So one thing that was really nice about FME Server is that it has a very sane REST API that you can use, and something that was a flow that we use is that we get a token, and then we just run the workspaces by a request to the server, and that was I don't know how well known it
You
is.
didn't mention that we had quite a time constraint on this
Yeah.
development.
Oh yeah.
so
Well, yeah. We had a really tight time constraint on this because I don't know a month or something.
Yeah.
That was about it. So we didn't have time to go through training and read all the documentation, all that. So this was that the REST API is so well built in FME Server was actually something that really helped us because it was very sane and so we wanted to say that. But we had a few things that we wanted to do that wasn't really supported by FME Server, and one of the things was fancy emails, the emails that you can get out of the different built-in functions.
it's the data download service.
Yeah, if you use the data download service, you get a very limited email on what you can do. So we put Python scripts at the end of all our workspaces that handles emailing, and it also does a few other things, such as zipping, because the data download service will zip everything, which is not good if you have, we have TIFF files, for example, that we distribute, and they're already compressed. When we try and compress that again, it takes about the same amount of time as it takes to extract the data. So we save some.
They don't get smaller.
No, so we zip it, but we do it without compression, and that's a lot faster. And we handle all that in the Python shutdown scripts. And that's a really, not only was the sort of API that we used to FME Server pretty sane, but there was also, when things didn't work the way we wanted it to, there's all these little tricks that you can use to get almost anything you want out of FME Server, which was really good. If we want some special custom functionality, we could easily extend it with that. And one of the ways we did that was Python shutdown script. However, this is not very nice in FME. You don't really want to sit and write Python in that little window. I mean, I grew up writing code for a Commodore 64 where I didn't actually have any media to store stuff on. So I can do that, but it's tedious because in Python, whitespace is important. It's very difficult to see the whitespace in there, and you have to do 3 or 4 clicks before you can actually run it, and you get the output from Python is mixed in with all the log files and all this. So that's not very nice. The kids today don't really like this. They need some more full-blown IDE. So what you can do in that case is you can just import your Python file. If you put your Python file in the same folder as the workspace path is actually added to Python's path. And in that case, you can just import it and then run it, or however you want to do it. We have an example of that. The other way, what we actually ended up doing is, because we don't have the Python files in the same space as the workspaces, we patched the sys in Python, and so that's example 1, as it says up here. I think we took that slide out. Another sort of trick of the trade is we have a very mixed environment because we deal with researchers. They use whatever they want. They use ArcMap, they use QGIS, they use FME. And so we've been looking into storing all our data in Spatial Light because it's one of the only things that we've found that will work in all these clients. And
yeah, we used to store in ArcSDE before, but since we got more and more QGIS users and they couldn't access the ArcSDE data, so we had to find another storing solution.
right.
So we were looking at Spatial Light then.
So one of the problems, I mean, the main thing we actually do with FME server is we clip data. We have very large data store, and then we extract a minor part of that. And a problem with FME is that when it reads Spatial Light, it will it won't actually use a spatial index that's in Spatial Light, and it will read through all the features, and then it will extract the ones that you want. Whereas most readers in FME you'll be able to set the spatial restraint to the reader, which is, we do that a lot when we deal with other data sources, but with the shapefiles it works brilliantly. But in this, with the Spatial Light, it doesn't work. So, but there's actually a way to get around that. This is what I'm talking about, that you set these values, and then FME will only read what's inside that box, which is basically, it's what we do in our application. This is basically it. But there's actually a way that you can get around that. You can create a Python creator and read the Spatial Light through Python. And then you can get this, in this example, there's 700,000 features in this little example database, and we're interested in about 3,000 of them, and it takes FME on the laptop a minute to read through it, but you can get it down to 2 seconds if you do it with a Python creator, which is very useful for us. Anyway. Do you want to do this one?
Yeah, just one thing that we do when, as a reporting function for we have different agencies that we deliver data to or from through this service, and they want to have some kind of statistics on how many downloads has there been for their data sets. So we use Google Fusion tables we read with an FME server workspace, we read the database, the PostGIS or Postgres database maintained by FME, and then we read all the requests and we compile statistics that we send to Google Fusion tables. So that's an easy way for us or for our providers of data to get some kind of statistics. But we've had some really big problems with the writer, the FME server writer, to write the Google Fusion tables, especially when the tables get big. So right now we're trying to write about 100,000 records to the Google Fusion tables, and it doesn't work well. So we're looking for some other way to do this, and as we heard today, there might be an option with this Google Map Engine. But
Yeah.
Yeah. So if any one of you have a good experience of that, we really like to talk to someone if it's how much it costs and how it works and so on. So please contact us.
Right.
Yeah.
Yeah, and this is, I guess, some things that
this is just something that we made. There's an option to use the KML network link as a service when you publish something on FME server, and we use this for keeping track on the daily download from this the GET service. So it just reads the same database and creates a KML file that you can publish, and then it will update every 60 minutes. That's what we set it to do. So it's just a tool for us to keep track of how the service is running, and it works really well.
Yep, and we're going to have time to actually show some stuff, I think. So the kind of results we've had now, we've been running it for a year and a half. And so we can do these sort of interesting things now. This is an old map of Sweden. It's the only sort of non-copyright one we could find. It's from the 16th century. And you can put like a heat map on it, and you can see that there's these hot spots where people are more interested in data than other places. But yeah, we have 23 universities right now that are using the service, and we have distributed 100,000 downloads, data sets, and we have around 6,000 unique users. And this is the questions and the links, but we'd show you. I think we have time. We can show you what it looks like. And this is I don't know.
Vad ska du visa?
Ska vi visa själva? Ska vi visa själva?
Nej, kör. Den finns där.
All right. Right. So maybe it wasn't obvious. Maybe I was a bit stressed because we were outside during the last presentation. We couldn't get in. So
This is the Federated.
Yeah. So what happens when you go to the services? The first thing that happens is this federation thing where you have to choose your university or where you're from, what provider you want to authenticate with. So we'll use ours, and Mats has been kind enough to put his password and stuff in here, so we can just authenticate with our university. And then you get into the application, and it works. And then you can sort of zoom into some area, draw a little area of interest, or something like this, and then
make it big so we can see that it changes color.
I
think that's a nice feature.
All right, you mean, so yeah, at some point it will go red because we have to put a limit. The idea of this application isn't to distribute the whole data set. It's more for individual researchers who are interested in sort of an area. Sweden is the...
I have a question.
Oh, right, sorry.
You said earlier with that selection thing that you're limiting it. Are you doing it by the bounding box or the number of features?
Bounding box.
Bounding box?
Yeah. It's because we mainly do it because we allow people to reproject the data, and that can take a very long time.
It's also because some of the data in here are really big. I mean, we have orthophotos, that's about 1 terabyte of data, and if people would try to download that, it would be some problems with the network.
Yeah. So you select your, what you're interested in, your data sets, and then you just go ready. We'll pick up your email, and you have to agree to the data license, and then you can choose if you want to reproject it between the two systems we have in Sweden. And then you just go, and then I don't know how your email works. No, I can show you what the emails look like in general. Let's do it this way, because we changed the default, or we do our own email.
So we had problems getting good looking emails from this data download service. It was hard to understand how to configure the mails, and we wanted to add some graphics into it.
Yeah, so we had a little picture and do a nice link and have a sort of suggestions box, stuff like that.
So people get this link and they click on it and download the data.
What else can we show?
You can tell something about the automatic deletion of files.
Oh, right, yeah. Yeah, that's another thing we do because we're kind of limited for space on the server. So we want to remove deliveries that have already been delivered. So in the shutdown script, in each workspace, we will go through the Apache logs and look for what's been downloaded and remove those zip files and folders and things associated with that.
So by default, in the FME server, you have to set just a time span for how long the files will be stored on disk. And in our case, we had many orders at the same time, and the disk got full. So that's why we have to do this.
Yeah.
It fires off each time somebody's making a new order. When the workspace runs, then you check for old files that have been downloaded before. Yeah.
This is actually the one that we just did. So we might be able to look at that one if the internet is fast enough. Right. So back to questions, and I think we're done.
Does anyone have any questions for Jacob and Matt?
Yeah. Oh, thanks. Yeah, we can look at this one. It's actually, we did, so it will be delivered as a folder. Inside these folders, we put, documentation, stuff like that. And it depends on what you order. And in this case, it's an order photo, so you get a shapefile of the extent and the metadata that comes with the shapefile, stuff like this. But then you actually get the actual TIFF. I don't know how this works as a Mac, but so you can look at it. I don't know. This was the area that we just did.
So what zipping technology are you using to zip those up?
Sorry?
What zipping technology are you using to zip?
Oh, we do it in Python. So in
Yeah.
Python, we can choose because we'll know what workspace was run,
Yeah.
and that workspace will tell us if it was a raster file or vector data. And if it's vector data, we zip it with compression. Otherwise, we zip it without compression. You can control that in Python.
Yeah, because we've actually had customer requests for exactly that behavior, to not zip things or to leave console files. It's probably your
It could have been yours.
Maybe.
So
or
we made it ourselves.
So you got to run the problem.
Yeah.
Okay. Well, that's great, you guys. Thanks
Yeah.
very much. If anyone's interested in a handout, they've got some up here of their coding.
Yeah,
examples.
it's the we in the handout we have basically this thing, the Python creator that does that. So if you're interested in Spatial Light and want to read it faster, and you know that you have a constraint, then that might be useful. And then we also have an example of how you can avoid using how you import or how you modify sys in Python too. It's
Excellent.
not rocket science, but
Great.
It's rocket science.
it is
It is rocket science.
Swedish
Yes.
rocket
so
science.
that's why you need the handout.